Hi students, today we will start naming of binary ionic compound and how to write formulas for binary ionic compound. And followed by naming polyatomic compounds. This won't happen in one day actually, so slowly we will learn one by one. So let's start with naming a binary ionic compound first. Okay, what are the rules? So bi means what? How many? Bi means two. So naming binary ionic compounds means naming ionic compounds with two atoms. Okay, so what is the first rule? The first rule is binary ionic compounds are made up of only two elements. Already I told that. So metal ions comes first. So we all know that ionic compounds are made up of two elements. One is metal, other one is non-metal. So which one comes first? So metal ions comes first, then non-metal ion comes second. So that is second. So this is the rule. So I might ask you in the quiz, which one comes first during naming, metals or non-metal? So you should write metals. So metals comes first, check. Non-metals comes second, check. Then name of this ion is the same as the name of the element. So whatever name you see in the periodic table for the metal, the same name comes for the ions too. For example, if you see sodium ion, then you call that as sodium. If you see magnesium ion, you call that as magnesium only. So nothing is changing. The same name comes. Then for the non-metals, the name of this ion is found by adding IDE. So at the end, you have to add the three letters IDE with the root word. For example, if you are taking fluorine, then it should end with IDE with the root word fluoride. If you see non-metal oxygen, then with the three letters IED at the end, you have to write oxide ion, not ion, oxide. So we will see an example. Let's take sodium chloride. Okay, so which is a metal, sodium or chlorine? We know that sodium. Sodium is a metal, so that comes first. Then chlorine is a non-metal, that comes next. So how do you write the name? I know always metal comes first, and you have to write the same name of the element which you see in the periodic table for the metal ion. No change at all, same. So sodium. Whereas when you see chlorine, you don't say sodium chlorine. You say sodium chloride. So the last name, that is a non-metal name, ends with the three letters IDE with the root word. So chloride. So chlorine becomes chloride. I'll show you the video after a few slides. So we will see a couple more examples also. So this is not the first and last time you are going to see the naming of binary ionic compounds. Okay, so I want to list out all the non-metals and I want to make sure how it's going to change when it comes in the ionic compounds. So can you guess how these non-metals can be written in a compound? So first one, fluorine, fluoride. And how about for the other non-metals like chlorine, bromine, iodine, oxygen? Then you see sulfur, you see nitrogen, phosphorus, carbon, and hydrogen. So how all these non-metals are going to end when you write their names in an ionic compound? So pause the video, take some time, then we will check our answers. Here you go. So fluorine, fluoride, chlorine, chloride, bromine, bromide. When you use this again and again, you will be really familiar with all these names. So you don't have to memorize everything. So once you use couple of times, you're going to get that immediately. Iodine, iodide, oxygen, yes, oxide, sulfur, sulfide. If you have written sulfuride, can you please change it? Nitrogen, nitride, phosphorus, phosphide. Have you written phosphoride? Then make a change. Carbon, carbide, hydrogen, hydride. So these are the ending names for the binary ionic compounds. So the non-metals are ending with IDE. So we'll be using this again and again for so many examples. Then you'll get that clearly. See, look at this. One more time, I just mentioned the rules. The first rule, cations. That is, metal ions always come first. We know that. 1 second, let me take. Okay. So cations comes, that is, metal ion comes first. Check, we know that. That is the first name. Then anions, that is non-metal ions, comes always second with the 3 letters at the end, suffix IDE. Okay, then I want to add a couple of things here. And so when you write the name like sodium chloride, always the first word may or may not be capitalized. See, when you write sodium chloride, the S for sodium, you can write as in a capital letter, or you don't have to. It doesn't matter. But the second letter should never be capitalized. Never be capitalized. So when you write sodium chloride, the first letter in chloride C should be in lowercase only. Okay, then come to the next one. If the compound consists of a transition metal, so I told you already, transition metals are a little complicated. They have more than one oxidation states. When you take sodium, sodium has only one state, that is one positive. It loses one electron, becomes one positive. But when you take transition, the transition elements can have more than one like oxidation state. Okay, so that's why I said a little complicated. So when transition elements are coming, how do I know? You might ask, how do I know what is the oxidation state? What is the charge of the transition metals? So to make your job easy, always you will see when you write the name, always you will see a Roman numeral. You know the Roman numerals, right? Like you write 1, then 2, and 3, and 4. See, yeah, I'm sure you're familiar with the Roman numerals. So you don't have to memorize the Roman numerals up to 100 or something. So just up to 7. I mean, that's enough, like a 1, 2, 3, 4, 5, 6, 7. Okay, you don't have to just simply I'm writing. Okay, that's it. Okay, so the Roman numeral will be included after the metal name to indicate the oxidation state or charge of the metal. So by looking at Roman numeral, you know what is the charge of the transition metal. We will see in the later on, I mean, the slides, we will see in detail. So now we will see some examples. See, NaCl. So what is the name of that? Na is sodium, Cl is chloride. Check. And Ba, barium. F stands for fluorine, so barium fluoride. K stands for potassium. H stands for hydride. So potassium hydride. Then iron, iron, so write iron, and chlorine. Chlorine becomes chloride. Do you remember in the fourth point I mentioned when you have the transition elements, you will see a Roman numeral after the name of the metal ion. The Roman numeral shows what is the charge of ion. See here the charge of the ion is 2 positive. Charge of the ion is 2 positive. Okay. So now we will do little practice. Take some time. I'm going to show you a few practice problems. Write the names of the binary ionic compounds. So you have MgO, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 problems. There are 10 compounds. The formulas are given. So take your periodic table. You should have your periodic table at this time. And pause the video and write the answers 1 through 10. Then we will check our answers. Are you ready? Can you go over the answers? First one, if you have magnesium oxide, check. Second one, sodium fluoride, aluminum nitride, potassium sulfide, lithium iodide. Put a check mark if you have the right answer. Calcium bromide, beryllium oxide, nickel chloride, magnesium nitride, and aluminum sulfide. I'm sure you must have 10 out of 10. Am I right? Okay. What we are going to see in the next slide, maybe the opposite. See, up to this slide, when the formula is given, you are writing the names. Now we are going to do the reverse. What is reverse? The names will be given. You have to write the formulas. So now we will learn how to write the formulas for binary ionic compound. Okay, so to write the formula for the given compounds, you should know the charges of both cation and the anion. So that is really important. So for both metal ion and the non-metal ion, for both cation and the anion, you should know the charges. Okay, so you know how to bring out the charges. And now I'm going to show you, you can note it down. If you want, you can note it down. But if you think that it makes sense, you don't have to write it. You remember, then you don't have to copy that pattern. Let me go to the pattern actually. See, look at this one. So now let's go to the first group. You know that first group loses one electron. See, everything is related from what we learned before. We are connecting the content. So group 1 has one valence electron. It loses one valence electron, so it becomes one positive. So group 2, it loses two valence electron, so it becomes 2 positive. We all know when it loses electron, it becomes positive. When it gains electron, it becomes negative. Then I told you the transition elements have multiple charges, and you will know with the Roman numeral. Now come to the third one. Group 13 loses 3 valence electron, becomes 3 positive. And group 14 has 4 valence electron, and it depends. It may lose or it may gain, it may share depending on the other partner, depending on the other atom it's joining. So based on whether it loses, gains, it becomes positive or negative 4. And come to group 15. Group 15, they have 5 valence electron. So they add 3 more electrons and becomes 3 negative. And group 16 elements have 6 valence electrons. So they add 2 electrons, becomes 2 negative. And group 17. Seven valence electrons, so they need one more valence electron and they become one negative. And group 18 have no charge. Group 18 has zero charge. So zero, that means no charge. You don't have to write the zero actually. So now, if you are able to remember this, that is really good. If, it's up to you. If you want to note it down, the pattern in your periodic table for the quick reference, just do it. Okay, I'm giving you time. So in the next slide, we will see a couple of examples how to write the formulas when the name is given. Okay, first example. So let me read the sentence what I have written on top. Cations and anions must be combined such that the total positive charge should be equal to the negative charge. Make sure to bring to the smallest ratio. So when we form the compound, that time I told you positive charge should be equal to the negative charge because the compounds are always neutral. They have no charge. Okay. Then make sure to bring it to the smallest ratio. We'll have some when you see some examples, uh, you might feel this is really easy. So let's take potassium bromide. So potassium is found in the first column. So charge for potassium is 1 positive. So charge for potassium is 1 positive. So let me write 1 positive, a positive one. Then bromine is found in group 17. So what is the charge for bromine? Bromine charges, it needs one extra electron. So negative 1 is the charge. Then to produce a neutral compound, see 1 positive, 1 negative. So check. See when you add 1 positive and 1 negative, they should neutralize. See, you get 0. That means no charge. See, that is a neutral compound. So that means we are doing the right thing. So 1 potassium needs 1 bromine. So the final answer is KBr. You note it down. You don't have to write 1 after potassium. You don't have to write 1 after bromine. If you are not writing anything, it means there is only one atom. If it is 2 or more than 2, then we will write as a subscript. Okay, we'll see a couple more examples. Okay, second example is magnesium chloride. So magnesium is in group 2. You know that with atomic number 12. Oh, I went to the next one. So magnesium, let me write magnesium symbol first because I'm trying to write the formula. So magnesium symbol is Mg and the charge is 2 plus. Charge is 2 plus. And chlorine. Chlorine is in group 17. We know that all the elements in group 17 has negative 1 charge. So now the positive and negatives, they are not same. See, there should be 2 negative because there are 2 positive. So to become equal, to become 0, you should have 1 more negative charge. So that means there should be 1 more chlorine. 1 more chlorine. See, now when you add 2 positive and 2 negative, that becomes 0. So the compound is completely neutral and we are doing the good job. We are doing the right job. So every magnesium, one magnesium atom needs 2 chlorine atoms to form the compound. So always we write the metal ions first and non-metal ions next. So magnesium 1, you don't have to write the 1 here. Then there are 2 chlorine atoms, write 2. You know, when you write the formula for the compound, you don't have to write the charges because the charges are getting cancelled. And positive and negative charges, they cancel each other. They are neutralized. We will see one more. And there is a shortcut method. You want to know what is the shortcut method? Yes? Okay, with the next example, I'll show you the shortcut method. Aluminum oxide. See, now you know the logical way with the first example and the second example. Now I'm going to show you some shortcut method, which is also crisscross method. The different name for the shortcut method is called the crisscross method. You might be thinking why that is called a crisscross. Is there any way, are we doing some crisscross things? Yes, you are. Now we are going to see that. Okay, so aluminum oxide. I know the symbol for aluminum is Al, and the charge for aluminum is 3 positive because it loses 3 electron. So 3 positive. Next, the non-metal is oxide, so oxygen ion, and oxygen is in group 16. So the charge for group 16 is -2 because it gains 2 electrons, right? Okay. So up to this enough. Then what is crisscross? I'm going to show you how to crisscross. So how I'm going to use the method crisscross. So something I'm going to do, the exchanging. So what I'm going to do is I'm going to bring the 2 next to aluminum. I'm going to bring the 3 next to oxygen. I'm going to bring only the numbers, not the charges. Okay, so let me rewrite that. So aluminum, okay, aluminum. Then crisscross, so swap the number. So bring the 2 next to aluminum. Okay, I brought it. Then oxygen, I'm swapping the numbers, but this time I'm swapping as a subscript. And I'm taking the 3 to the opposite. So this is the final answer. So what does it mean? It means 2 aluminum atoms need 3 oxygen atoms to form the compound. You want to check, are we doing the right thing? How do I check? I'll show you how to check that quickly. Okay, whether this is right or not. See, aluminum. So there are 2 aluminum, right? So 2 aluminum. One aluminum is positive. So positive 3. So how much is 2 aluminum atom? Positive 6. That is right. Together. I'm just putting together. Then one oxygen is -2. We know that. And I told you there are 3 oxygen. You see the number 3? So 3 oxygen. So how much is 3 times -2? Yes, you are right. -6. So if you are doing our job correct, then that should be 0. Yes. See, positive and negative charges are equal. So that means we got the right answer. We are doing our job correctly. So let me explain you one more time quickly. Then we are going to do some practice problems. So first write the symbol for aluminum and oxygen and write their corresponding charges. Then just swap the numbers, period. If you want to check whether you have done the right job, just multiply the charges with the number of atoms and make sure you have 0 at the end when you add the charges. So this is the final answer for aluminum oxide. Are you ready for some practice? I paused the video. So let me know if you want me to explain one more time. I can do that. Okay. Okay. Oh, there are a couple more. See, write the formulas for the compound. See, just they are crisscrossing. And I want to take the second example actually. Particularly, I want to work on the second example. You might be thinking, when you're swapping the numbers down, you must be getting Mg2 and O2. Sorry, not O. It's sulfide, right? So it's S. So sulfide 2. Do you remember the rules? The number should be in the lowest possible ratio. So can you simplify 2 and 2? Can you make it as, can you reduce the 2 and 2 ratio? Yes, you can, right? It can be, both numbers can be divided by 2 and you can go to 1:1, 1:1. So that means just magnesium 1 and the sulfide 1. So you can minimize that. Then already you know when there are 1, you don't have to write the 1. Just you can leave it. See, MgS. So just I want to show this particular example because I mentioned it should be in the lowest ratio. Okay. The same thing here. You will be having I'm working on E. See, yes, N. When you crisscross, when you swap the numbers, S and O4, and you can simplify 2 to 4 as 1 to a 2. So that's what you are having this answer. Any questions? So now you tell me, is this crisscross method useful? It's easy to do. You want to see a video for this? I have a video for this. So I'll show you the video once, then you will do practice. You will find the video in the next slide. Okay, this is the practice, right? So I might be having the video in the previous slides. Let me go back. Yeah, I think this is the video.
The crossover method is a shortcut way of writing formulas for ionic compounds if you know the charges on the ions in the compound. We'll go over a few examples. In example A, we're asked to write the formula for magnesium chloride. Looking at magnesium on the ion table or periodic table, we see it's Mg with a charge of 2 plus. And chloride is Cl with a charge of minus or minus 1. We start the formula by writing down the symbols Mg and Cl. Now we take the 2 from the charge on the magnesium, cross over, and write it next to the chlorine. Now we could take the 1 from the charge on the chloride, cross it over, and write it next to the magnesium. But we don't use the subscript 1 in a formula, so we don't need to write anything. So the formula has 1 Mg and 2 Cls. So we'll compact it and write the final formula for magnesium chloride as MgCl2. We'll check the charges to verify that this formula is correct. We have 1 Mg2 plus ion and 2 Cl minus ions. So the total charge is positive 2 plus 2 times negative 1, or positive 2 plus negative 2, which is equal to 0. So the formula MgCl2 is correct. Example B asks us to write the formula for calcium oxide. We look up calcium and it's Ca with a charge of positive 2, and oxide is O with a charge of negative 2. We start the formula by writing down the symbols Ca and O. The charge on calcium is positive 2, so we cross over and write a 2 next to oxygen in the formula. The charge on oxide is negative 2, so we cross over and write a 2 next to calcium in the formula. Notice we always drop the negative when we write subscripts. Now we have the formula Ca2O2. But you can see that both of the subscripts in this formula are divisible by 2. So we simplify and divide both of these by 2 and get ones. We do not keep the subscript 1 in a formula, so we remove the ones, leaving us with the formula CaO, which we'll compact and write as the final formula for calcium oxide. Checking charges, we have one Ca2 plus ion and one O2 minus ion. So the total charge is positive 2 plus negative 2, which is equal to 0. So this formula is correct. Question C asks us to write the formula for chromium 3 sulfide. The chromium 3 ion is Cr3+, and the sulfide ion.
See, do you remember when we talked about the transition elements? I told you that charges will be shown in the Roman numerals after the metal ion. See, chromium, Roman numeral 3. So that means the charge for the metal ion chromium is 3 positive.
Ion is S2 minus. We start the formula with the symbols Cr and S. We take the 3 from the charge on the chromium, cross over, and write 3 next to sulfur in the formula. And we take the 2 from the 2 minus charge on the sulfide ion, cross over, and write 2 next to chromium in the formula. There is no number other than 1 that will divide into 2 and 3, so this formula cannot be simplified. So the final formula for chromium 3 sulfide is Cr2S3. Checking charges, we have 2 Cr3 plus ions and 3 S2 minus ions. So the total charge is 2 times positive 3 plus 3 times negative 2, or positive 6 plus negative 6, which is equal to 0. So this formula is correct. Question D asks us to write the formula for palladium 4 oxide.
Again, you see Roman numeral 4 after palladium. That means the charge for palladium is 4 positive.
Side. Palladium 4 is Pd with a charge of 4 plus, and oxide is O with a 2 minus charge. We start the formula with the symbols Pd and O. We take the 4 from the charge on palladium, cross over, and write 4 next to oxygen in the formula. We take the 2 from the charge on the oxide ion, cross over, and write 2 next to palladium in the formula. Now we have the formula Pd2O4. But we see that both of the subscripts 2 and 4 are divisible by 2. So we simplify by dividing the 2 and the 4 both by 2, giving us 1 and 2. We remove the subscript 1, leaving us with the formula PdO2, which will compact and state as the final formula for palladium 4 oxide. Checking charges, we have one Pd4 plus ion and 2 O2 minus ions. So the total charge is positive 4 plus 2 times negative 2, or positive 4 plus negative 4, which is equal to 0. So PdO2 is the correct formula for palladium 4 oxide.
I hope the examples you saw in the video are really useful. Okay. So there are 4 examples in the video, and all these examples are completely different from each other. So that was really useful. Now ready for practice? Yeah. So write the formulas for the compounds. So first one is potassium oxide, second one calcium iodide, and third one iron 2 oxide. So the Roman numeral 2 means the charge for the ion is 2 plus. The fourth one is copper 3 chloride. So when you see the Roman numeral 3, that means the charge for the copper is 3 plus. Okay. So pause the video. Before passing the video, quickly I'll go over the steps. Write the symbols for the metal ion and the non-metal ion. Then write the charges. Then swap or cross over or crisscross only the numbers. Please don't write positive and negative sign. Okay, so take time. And here are the answers. I hope you all have 4 out of 4. Let us check the answers. Okay, this is the end of the video for today. So in this video, we watched how to write the names, how to write the formulas for the ionic compounds, binary ionic compounds. So if I give the formula, you know how to write the names. If I give the names, you know how to write the formulas. Okay, so I hope the video is really useful. The recorded video is really useful, and we will do a little bit more practice in different ways.